Okay, welcome everyone to the stream. I see a lot of you have joined. Today we're gonna continue the blog series beyond XSS. Those are pretty interesting series, but I guess some of you might want to see the recon. So I guess for the next stream I decide to do a little bit of reconnaissance, just not like stay on XSS all the time. So it will be a little bit of break from like usual stuff. So sometimes breaks are pretty good as well. But today we're gonna check some defense and bypass for XSS. Like if you want to be a good attacker, you have to understand how defenses are being placed from the defensive side, how developers are trying to protect against you. And if you understand this, it will be way easier for you to see if this is like could be exploitable or not. All right, so let me share the screen. As you can see, our goal is 14 people left to reach our goal. This is followers on Twitch. Hopefully until the end of the month I could reach that, but we will see. I like in the first week a lot of people joined, but right now it's going, I don't know, like plateau or something like that, but hopefully we can get yeah, I see people on YouTube are chatting with my bot. That's nice. Nice. Hopefully I gonna hide this goal for now, just like for everything to be visible normally. So let's start probably. After discussing the various basics of XSS techniques, let's talk about defense. Starting from this post, we will officially enter chapter 2, the defense and bypass for XSS. So bypasses are a very interesting topic. I already on some streams have shown like how you can set up like pretty basic Cloudflare firewall and some labs. So if you haven't seen that, you can easily find it on Twitch or YouTube, so have that in mind. And I have also a GitHub repository also created if you want to play around with different XSS contexts, so you feel free to do that. Okay, as mentioned before, when discussing XSS defense, we can encode user input to prevent it from being interpreted as original meaning, thus avoiding risks. In addition to encoding, there is another method that is more like removing harmful parts from the user input. This operation is called sanitization, and the program responsible for handling it is usually called sanitizer. There are some subtle differences between this and previously mentioned encoding or escaping. Encoding encodes specific characters in user input, which will still be displayed as the plain text. Sanitization, on the other hand, removes the entire part and does not comply with the rules, deleting it completely. Before getting into the main topic, we will take a look an answer to the previous post. At the end of the previous post, I posted this piece of code and asked if anyone had any questions. Okay, so it's basically using JavaScript as far as I understand. It's using constant variable value from the user. I guess the value from the user will like be saved in this variable. And if URL starts with YouTube, iframe equals source. Okay, let's see where is the problem with this code. The problem with this code is the validation for the URL is not strict enough, allowing users to input non-video URLs, such as like it will start like this. You can see the verification. It will check. It will definitely start like this, but you can apply // so it will be just some path traversal attack, which could lead to account settings page. but that doesn't sound too bad, right? It's just another YouTube page and it could still be within YouTube. Yeah, from the first sight it is, but I know that this could be still abused if you can like put the XSS in some other page. Well, if you chain vulnerabilities, for sure that could be an issue. Alright, in theory that's correct unless the website has an open redirect vulnerability which could redirect to any URL. In that case, the attacker could control the content displayed in the iframe. For example, if youtube.com redirect target equals blog Hulit Taiwan redirects to this blog, I can use this URL to make the iframe display on my blog instead of expected YouTube video. Yeah, so if you chain that with open redirect, it could be exploited even further. And indeed, YouTube currently has URLs with open redirect that could be exploited. I guess this is like real huge problem with Google. They do not accept open redirect vulnerabilities, and they have a lot of open redirects, especially in Google. And you might know that YouTube is also in the same company. I think it's called Alphabet or something. So the YouTube is part of the Google. That's why the same problem is still like they have a lot of open redirects, and those could be abused for sure. But this is not like at the first sight it won't look like a real big issue, but eventually if you're like smart enough, you can like solve the puzzle, chain multiple vulnerabilities, and it could become like even higher problem for sure. All right. Okay, open redirect can be exploited. However, since they can be fixed at any time, I won't provide the URL here. Yeah, even though they won't say this is like a big issue for us, we won't award for open redirects, but still, like disclosing those could be against their policy. So I guess I understand the author for not doing this, even though we don't care that much about those issues. If you need to validate URLs, the recommended approach is use the new URL method for parsing and make judgments based on the return value. This method is much more robust than simple string comparison using regchecks. Now we've finished the quiz, and let's talk in detail about how handle user input. So basically just check the defensive side. So the most basic measure is encoding. We already saw some of the encoding for some characters like double quotes, single quotes, and open tag character. I'm not sure like how it's opening bracket probably and closing bracket, or I don't know. But yeah, okay, why does XSS attack work? Because engineers expect user input to be simple text input, but in reality, the input is interpreted by the browser as part of HTML code. This difference creates the vulnerability. It's similar to SQL injection, where I think you're entering the string but interpreted as part of SQL command. Yeah, like any attack is basically when you send the payload what it's not intended. Like if developers are creating the program and they expect certain parts of parameter values, they also have to filter them out, encode, validate, because users should be not predictable easily, because there will be malicious users for sure. So that's why this is necessary actually. Therefore, the fix is simple: encode the user input and make it appear as it should. In front-end development, when putting user input on the screen in JavaScript, remember to use inner text or text content instead of inner HTML. This way, the user input will be interpreted as the plain text. Yeah, so this is like another way. Both React and Vue have built-in similar features. Okay. By default, everything rendered will be treated as the plain text. If you need to render HTML, use special methods like dangerously set inner HTML. This is on React, or VHTML on Vue.js. So in case you have some like broader knowledge and you will be able to obfuscate the like minimized JavaScript code, if you see those functions, you have to look for those because they have some abilities that it could be potential for XSS, unless those functions does not get like the data in those functions are not getting from the user. So in that case, it's less likely, but you have to look for those for sure. As for the backend in PHP, you can use HTML special characters function. The table in the documentation shows which characters it encodes. So yeah, validation is actually to do that type of validation actually in the backend, because not every time just using front end it will resolve anything. So yeah. All right. Let me quickly write something. Okay, let's continue. So in the backend, HTML special characters function, this is in PHP, but there are way more backend frameworks, so it will be different functions for the different programming languages for sure. All right. So this is like how those replacements will become. So for example, ampersand will become this, double quotes will become this, less than sign and greater sign, like it will become those type of things as well. Okay, however, nowadays many backends don't directly output content. They use template engines to handle it. For example, the command used handlebar.js treats name as encoded output by default. To output raw content, you need 3 curly braces, like vulnerable to XSS. In Laravel Blade, this is encoded while this is not. I wonder if exclamation mark is warning, hey, be careful then using this. Yeah, so he is basically just saying, even though something is done in the backend, it could be like there is possibility to do template injection. So we will, I guess we're gonna talk about template injections a little bit more as well. So let's see, some template engines use filters. For example, Python's Jinja is encoded, while this means that the content is safe and can be directly output as original format. So yeah, you just need to use safe. Okay, therefore when writing code, it's best to default to safe approach. Pay attention to unsafe parts, including the previously mentioned href that require special attention. So yeah, I guess from the first side, I've just seen the most of like recommendations for developers to develop secure code. So the main takeaway is when you have a chance to see front-end functions, just in case if there is some front-end code leak obfuscated, just look for those functions, because they have leads that it could be possible to do XSS, but you have to trace where your user input, from which area your user input is like going to those functions. So those like dangerous functions are called sinks, and the places where user input is being parsed is called sources. So you have to trace sources to the sinks when like doing source code analysis. All right, we can read this, but let's see other part as well. As the saying goes, use library that someone else built, but don't try to reinvent the wheel. Well, still, like, even by using some libraries, there will be vulnerabilities in some third-party libraries, and a lot of pretty good companies, which their developers are pretty good, they write pretty good code. If they decide to use third-party libraries and those libraries aren't being vetted pretty well, there is like higher chance of getting bugs for sure. The more libraries use, the higher the chance could be as well. So yeah, if the framework or programming language you are using provides relevant functionality, use it. If not, find well-reputed library that it's widely used. Yeah, if it's widely used and reviewed by many other developers, I guess then it makes sense. But still, even I could give you an example. For example, there was a vulnerability called shell shock. It's kind of old vulnerability. It was used in like bash programming language, but that vulnerability actually existed 20 years prior to discovering it. So even though that open source code was seen by many people, but not all of like I don't know, maybe someone discovered but haven't told anyone, but it took 20 years to discover a vulnerability even though it was on the source code. So this is like one of the examples. Another example, like log4j, was also like heavily exploited, and that library was used by many people, but still that was like many people missed this. All right, so even though if it's being used by many people, there is still some chance that many people have missed it as well. All right, of course these libraries have vulnerabilities. That's right, what I was saying. That's inevitable, but they usually consider many scenarios and have resolved many issues, so they are much more thorough when you want to do it your own. Yeah, especially if you are the beginner developer, it makes sense to reuse the code that many people are already using, right? Moreover, these libraries just specifically designed for sanitization purposes. All right. For the Python, has a library called Beautiful Soup, which can parse web pages commonly used for web scraping. However, it's not designed for sanitization, so using it may lead some issues. Yeah, and other interesting thing about Beautiful Soup, sometimes it could be used on some websites as not intended, like not as a crawler. Sometimes it could be used as like screenshotting tool or some weird way, but it's not supposed to, and then it could lead for even like some server side issues. So I seen some SSRFs probably not using this particular library, but the way how developers like poorly designed the website. So even like the library itself is not really bad, but if it's not used intended way, it could lead some issues for sure. Okay, even though it's not designed for sanitization, it is used for parsing web pages, right? So why can we use it? Let's demonstrate. All right, so this is like small Python code. It is backend language. This is like importing that library. This is just a HTML code saved to the variable. Tree, it is like another variable, and it just parses this HTML. And this tree, I guess it will save like different HTML tags as like tree dataset, and it will loop through each of that element, and it will print to the screen, for example, the name and attributes of like each element. So yeah, this is the output. It seems fine, but it parses tag names and attributes correctly. So can't it just create an allow list to block list myself? It sounds reasonable, but actually, well, yeah, imagine if this coming from like malicious user. So this is using HTML comments, and even though on the output it doesn't show anything, it seems normal, but if you open the HTML in the browser, you will see our beloved pop-up window, including that JavaScript has been executed to check by beautiful soup has been bypassed. Yeah, so he's just saying, if you're developing the websites, just use the libraries what it's meant for sanitization. Just don't use like other libraries to do sanitization. Like, use case matters, I guess. The bypass is based on the difference parsing between browsers and Beautiful Soup for the following HTML. Beautiful Soup's HTML parser treat this as a comment enclosed by those and won't parse any tags or attributes. However, according to HTML5 specification, this is valid empty comment, so when the above becomes comment followed by script tag and the text, okay, comment start, comment end, but in the browser, so this is like a discrepancy between like Beautiful Soup HTML parser and the browser specification. That's why the payload works here, as we can see. Exploiting this parser difference, an attacker can bypass the check and successfully execute XSS. By the way, if you switch Beautiful Soup's parser to LXML, it won't be able to parse it correctly. But if you switch to HTML5 lib, it will correctly parse script tag. However, it might be other issues with HTML5 lib. Alright, okay. Let me check the chat. Okay. That's cool. Okay, let's continue. DOM Purify is open source package developed by Cure53, a German cybersecurity company specifically for HTML sanitization. Cure53 has many members who specialize in web and front-end development and have reported numerous well-known vulnerabilities. They are experts in this field. So basic usage of DOM Purify as follows. So it has the sanitize function for HTMLs, and it could be saved to the constant. It does a lot of behind the scenes, but only removing dangerous tags and attributes, but also defending against other attacks like DOM clobbering. Alright, I haven't actually yet explained about this type of vulnerability, but basically it's like very thorough sanitization framework or library. DOM Purify allows only safe tags by default, such as h1, p, div, span. It also removes all the event handlers and clears out the JavaScript pseudo protocol, as mentioned earlier, ensuring that any HTML you input will not result in XSS default scenario. Alright, I guess if there is the bypass for DOM Purify, I'm gonna create the lab for it, but we will see in the series because I haven't experimented myself. I guess this library is relatively safe, but let's see. But one thing to note that the style tag is enabled by default, and we will discuss the related risks later. Alright, style tag. So I guess CSS injection, which is also another type of vulnerability. It's not XSS, it's client-side bug, but it could lead to some serious things for sure. If you want to allow more tags or attributes, you can adjust relevant strings. So yeah, you can even add tags even though it's not allowing, and you can allow strings. This is HTML, and you can use that configuration. So yeah, Sometimes developers will enable those just for a functionality purpose, because they won't care that much about security. They will care more about functionality, and bad things could happen as well. Okay. From the example above, even if we allow a source attribute of iframe tag, the dangerous content will be automatically filtered out. This is because we only allow source attribute, but not allow to use JavaScript pseudo stuff. However, if you want to allow some attributes or tags that could use XSS, DOM purify won't stop you. So yeah, if developers make mistakes, even with this library, it could be possible. So like another takeaway, if you see certain libraries being used, certain frameworks, doesn't give up so soon, because still developers make mistakes. And as you can see, with fairly good, fairly decent library, it still could be bypassed if developers are making certain configurations. DOM Purify's documentation is quite detailed, and there is a specific page called Security Goals and Threat Model that explains goals of this library and situations which issues may arise. Okay, correct library, incorrect usage. So yeah, that basically it was covered before. Then using these libraries, it's important to learn how to use them through the official documentation and pay extra attention during the usage. Even with this correct library, incorrect configurations can still cause problems. The first classic case is vulnerability discovered with well-known Taiwanese hacker Orange in 2019 when filtering content. HackMD used the following configuration. HackMD uses different package called XSS. Okay, so it's basically replacing a lot of stuff, as I see. But let's see the explanation. I don't want to waste time explaining everything if there is explanation already. So let's see. If the tag is this, it is directly ignored and not returned. The intention was to preserve comments. For example, those hello would be treated as the tag named this one. However, the Orange bypassed it using the following method. Okay. Since this was treated as a tag, the content above adds few attributes. Then then the browser renders it. The opening, this combines with this bar in the foo, becoming in the comment, and the following s high closed s is displayed, resulting in XSS vulnerability. Okay. So this is tag start, tag end. So I guess this is another example of discrepancy between library and the browser behavior, and this is why you have to like create your own lab and test yourself what works, what's not. That's why I highly recommend to like setting up everything and trying to see if you can even spot 0 days. For more detailed information and the fix, please refer to the original article. I also discovered a different case in this, but it was a misuse. Okay. The website. Dangerously set inner HTML. Alright. There is a lot of code analysis right here, but basically I just wanted to like check few key takeaways. Is like, even if the website uses strong frameworks, strong libraries, you have to understand that mistakes do happen, and you have to actually try to experiment yourself. So like adding some comments, like trying to break with some characters. I recommend, if you are just a beginner, check my stream about polyglots, because I shared a lot of tips like how you can build your own, where to find those, and basically those will try to escape a lot of libraries, a lot of frameworks. But of course manual work is the best approach. Like go like very small step ahead and see what works and what's not, and then you could probably try to bypass. Of course not every time it's gonna be possible, but it is like how it goes usually. So yeah, let's see other article, the second line of defense against XSS. So on the first article, the sanitization part from the code itself, there are different libraries how you can sanitize, but there is like another layer of protection what people are using. Not every time, but I seen those type of defenses. So usually if I see CSPs, it's very unlikely that you're gonna exploit anything, but there is some chances for sure, but still. Okay, the first line of defense against XSS is to sanitize user input and ensure that content is safe. However, it's easier to say than done, especially with legacy projects. This is exactly what I was actually saying. If the website was built a while ago, it's really hard to like push a couple of lines of code, because it might crash all the websites. So sometimes like adding firewall or adding some kind of CSP protections is a way to go for the legacy systems. All right. It becomes difficult to determine where to make necessary fixes. Exactly. Furthermore, the mistakes can happen while writing the code, and there are three main reasons for security issues. You are unaware that certain actions can lead to problems. You forget that certain actions can lead to problems. You are aware that certain actions could lead to problems, but due to project deadlines or instructions from superiors, you choose to ignore them. Yeah, so that what actually, in this case, what actually happens as well for the developers. They have so many things to do apart from fixing issues. So that's why they might use some, I don't know, very simple approaches instead of like reading the code what was built 10 years ago by some developer which is not currently working in the company. So sometimes it's even easier to like put some second line defenses like CSP. All right, the first reason is similar to example mentioned earlier with ahrefs, where you might not be aware that it could execute code JavaScript like this. Second reason is when you are aware that of XSS vulnerabilities, but you know that output should be encoded, but you forgot to do so. Yeah, forgetfulness, not knowing, and some deadlines. The third reason is knowingly leave the vulnerability unencoded, even though it should be encoded due to project time constraints and instructions from superiors. Yeah, that is, I think this is one of the most common ones in some companies. In the case of the first reason, where you have no idea where to handle the issue or there is a vulnerability, how you can defend against it. This is why you need the second line of defense. All right. So the CSP, short for Content Security Policy, allows to establish rules for your web page and inform the browser that only the content that adheres to these rules should be allowed. Any content that does not comply should be blocked. So yeah, you just basically are using special header in, like, you will specify in the browser as developer and say like which content should be blocked and which one is not. There are two ways to add CSP to web page. One is through the HTTP response header, a content security policy header, and the other is through the meta tag. Since the latter is easier to demonstrate, we will focus on that, although the former is more commonly used and some rules can only be set through it. There is also mysterious third method involving CSP attribute of the iframe, but this is a different topic we won't discuss here. Okay, so he will just show like how you can use meta tags to describe the content security policy. All right, so it will just use these parameters like script source to none. In the above web page, CSP is declared to script source none, which means no script execution is allowed. Yeah, on this web page. Therefore, the script in the body will not be executed. If you open DevTools, you will see the following error message. Refuse to execute inline script because this violates the content security policy directive, like this one. Either the unsafe inline keyword and the hash, blah, 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 blah. So basically you're not able to execute code even in your console while you're on this page. That's what content security policy does basically. Okay, this why I refer CSP as the second line of defense. When your first line of this defense is handling user input fails, you can still rely on CSP to prevent loading of scripts or other resources, effectively preventing XSS. Okay, CSP allows you to define directive along with rules. As the example above, directive was script source set to none, which ultimately blocks the execution of any JavaScript. First, it's important to note that the directive script source should not be easily interpreted as source attribute of script tags. There, the term script refers to general scripts, not specifically script tags or source attributes. So, for example, if there is a HTML snippet like this, href JavaScript alert, click on the page which does not have script tag or source attribute, it will still be blocked by CSP. So this is pretty good browser security. And the error message will be displayed. This is because script source none means block the execution of any JavaScript. So yeah, whenever it's through the script tags, event handlers, or even like pseudo protocol of JavaScript. Okay. So what are the available directives? The most important one is default source, which represents the default rules. For example, if script source is not set, the rules from default source will be used. However, it's important to note some directives do not fall back to default source, such as base URI or form action. You can find the complete list right here. Okay. Oh, there is even a website called contentsecuritypolicy.com where you can read how basically CSP works. Okay. So, but he just summarizes it, other commonly used directives. So, for example, for JavaScript, you will use script source. For CSS, style source, because still, if you are blocking JavaScript, there are other attacks like CSS injection that could happen. So using this one as well, it's also pretty interesting. Fonts, not so interesting. Images also, like for us, maybe like when we look which type of defenses are in place, we just usually look for those mostly. So there are many types, right? And this list is subject to change. For example, Navigate 2 at the end of the newer feature is not yet supported by current browsers. In addition to these, there are actually many more, but I didn't mention the less commonly used ones. If you are interested, blah, 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 blah. Okay, so what are possible rules for each of these? Depending on directives, different rules could be used. So yeah, so those are like directives. For example, right here is directive, and right here is the rule, like how you can specify in meta tag. So sometimes you need to check on the website like if there is a meta tag for content security policy, and sometimes you also have to check the HTTP headers as well, because those could also have those. So the rules, there is the SAR, so basically allows URLs, all URLs. So basically this is unsafest one. So allows all URLs except data, blob, and file system. None is doesn't allow anything, so it's like best protection. Self only allow same origin resources. I guess he will say what is origin, but if you don't know what origin means, check some of my previous streams as well. I like explained a little bit what is origin and like how to differentiate which is like same origin and which is not the same origin. HTTPS allows on HTTPS resources, like specifies special domain, and like specify the scheme plus domain as well could be possible. All right, but sometimes those could be bypassed, so keep that in mind as well. For example, script source is basically equivalent to not setting any rule. So this is basically, even though if you see content security policy, meta tag, or a header, but if it uses star, it's basically the same as nothing. So yeah, just look for those. So not setting any rule allows all URLs, but it's worth noting, but inline script is still blocked, while script source none completely blocks the execution of any JavaScript. Furthermore, some rules could be combined. In practice, you often see rules like this. All right, so yeah, you can see like you can load the script from the same page from certain CDNs, but if you try loading a script from like your own malicious website, in this case you will get blocked by the browser. Okay, sometimes scripts are hosted on the same origin, so the self is needed. Some scripts are hosted on CDN, which is also required, and because of Google Analytics and Facebook SDK are used, we use those. It's needed to load their JavaScript, so basically for analytic purposes. The complete CSP is combination of these rules with directives separated by this character. So yeah, you can like specify directives plus rules. So default source none, like multiple rules you can see. Through CSP, we can inform the browser which resources are allowed to be loaded and which are not. Even if attacker finds an injection point, we were not able to execute JavaScript, thus mitigating the impact of XSS vulnerability. Although it still needs to be fixed, but risk is smaller. Okay. Let's see. Okay. There is good. I just wanted to check if he is talking about CSP evaluator. So this is good because I wanted to show you this as well, but we can continue reading this. Okay, in addition to specifying the URLs of the resources to be loaded, there are other rules that can be used. For example, after setting CSP, inline scripts and eval are blocked by default. The following inline scripts are blocked. Code directly placed in script tags should be loaded from external source using script source. Event handlers written in HTML such as onClick, the JavaScript pseudo protocol. To allow these inline scripts, the unsafe inline rule needs to be added. If you want to execute code, if it's where eval, you should need to add unsafe eval rule. Some people may know that, that set timeout could also execute code as string like this. Set timeout. All right, this is interesting payload for sure. Similarly, set int_val function as well could be used, and others can achieve same thing, but we all require unsafe eval rule to be used. So this is really in-depth explanation about like CSP. Yeah, so okay, the rules can even be used like by SHA-256, so it will be hard to read those. I rarely see those type of rules, but I guess that's possible. So okay, so yeah, you can use the website to like obfuscate certain things. Yeah, only this type of code will be allowed. So yeah, this is pretty good defense if it's intentional, but yeah. Okay, finally there is one more. They might be used. Script dynamics means scripts that comply with rules can load other scripts without being restricted by CSP like this. Okay. In the CSP we set only this allowed for scripts and no other sources are allowed. However, the scripts added from within script nonce are not restricted and can be dynamically add scripts from other sources. This is the function of script dynamic. Okay, but I guess the most important part is here for the attackers, how to determine the CSP rules. So I guess that CSP evaluator is very interesting one, where you can basically put the URL or the rules itself, and what it will do, like if you put your CSP code, it will say what is allowed to do on that website or not, like to more human readable code. So the CSP still could be poorly configured, and it could be even like similar to having no CSP protection, as we saw, like using the star is extremely dangerous. It's same as using no rule basically. So yeah, there is a lot of like how you can do this, but basically when you see a lot of things like this, what you can do is just paste it right here, and even though it looks scary, but you can see that, for example, for where is the script? Fonts, frame actions. Okay, it's just saying where you can for example, from where you can load images. Like this could be used for specification, but what's actually the most interesting for us attackers, if you paste those content security policy rules and check the CSP, what you are looking for is a high severity finding or medium severity finding. I don't recommend reporting if you like see weak CSP policy, because those will be marked as not applicable. But just have you have to check those before like trying XSS payloads, because those could be used to prevent for some attacks. And if you understand which defenses are in place, it will be huge time saver for you for sure. So yeah, basically just use CSP evaluator with google.com. This website is really good for that case. Yeah, so basically this is how Facebook uses CSP. And if we try to paste this here, we can see that this has some flaws for sure. In some of websites, the CSP could be bypassed. For example, JSON-P endpoints allow to bypass CSP. So, but basically you have to find the bug on other website and then chain with current website to fully exploit it. All right, so okay, the Facebook, although it's long string, you can notice, but unsafe inline is enabled for scripts, which is less secure approach. If you paste this CSP into CSP evaluator, you will see a lot of red flags, which you're basically looking for. So yeah, the main takeaway is just try to use this website when you see certain content security policy, and then try to read which directives and which rules are interesting, and those might get you some leads where you can try some bypasses basically. Yeah, so conclusion, I personally recommend setting up CSP. Again, this one is for defensive side. Once it's configured, it adds an extra layer of defense, giving us a chance to mitigate many issues. By blocking XSS payloads from attackers through a CSP, we can minimize the damage. Yeah, so this is like, yeah, really good second line of defense for the developers, but not every time that will be used for sure, because it's sometimes along the development life cycle, the developers might decide that they need to use some extra websites, and when you add extra website, you're gonna need to configure CSP also. And if more and more websites are being added each day, it becomes pretty not so good for development purposes. So that's why some of the websites, some of the developers won't even use the CSP, either by because it has some minor inconveniences, or because we just don't know what it is exactly. So that is also could be the case. And there is a third line of defense against XSS, the reducing the impact scope. Okay, so this is pretty big article. Let's probably see what it's about, and we will see if we're gonna read it or not. The first line of defense, we processed user input to ensure encoded and sanitized, preventing insertion of malicious content. Second line was CSP, which prevents the execution of JavaScript and loading external resources and even malicious content inserted. Now let's discuss the third line of defense, which actually assumes that XSS will inevitably occur and formulates protection strategies based on this assumption. All right. Some may wonder, why do we need to do this? Shouldn't we just the first two lines of defense will be enough to prevent XSS attacks? Why do we need to assume that XSS will occur and develop strategies to mitigate the damage? Isn't this putting the cart before the horse? Okay, let me give you an example. You have probably seen movies like Mission Impossible, where the scenes involving the theft, the place where valuable items stored, is always designed with multiple layers of security measures. There are retina recognition, facial recognition, voice print recognition, and even walking posture recognition. All right. After passing these checks, you will still need a key to open the vault door. Inside the door, they might be safe where you need another set of passwords to open the safe finally. Okay, he's just basically telling what, even though if there is a couple of lines of defenses already in place, adding extra layer is not a really bad idea, because you will be way safer in this case. Okay, so the reason for having multiple layers of security is simple: to increase safety. Although some designs may seem secure, you can never guarantee that they won't be breached. Therefore, additional layers of protection are needed to ensure that only when each layer is breached, there will be damage, thus increasing the cost of the attackers. Okay. Okay, same principle applies to cyber. Yeah, I guess this one is not that much technical. Article, taking possible measures. Okay, so this is very generic one. I won't even bother reading it. I'm not that I'm getting tired of reading, but this is really generic things. I don't know. The most effective solution, multi-factor authentication. This is very generic thing. Okay, preventing token theft. Okay, the limit API calls, limit token scopes. All right, I guess this one is not so interesting one, so we can try skip this one. Trusted types. Let's see, the latest XSS defense, trusted types and built-in sanitizer API. Okay, this one I guess it's way more interesting. So I guess for today we gonna finish with this article. Still gonna see like this article as well, and because I guess for today we will like explore all of the lines of defenses. Not all of those will be necessary, like for the most cases there will be only first line of defense or even no lines of defense. Like even in the real world applications there might be extra layer of defense with web application firewall, but that's basically gonna be it for the most part. But okay, let's see the last article for the defenses. When discussing XSS defense, I mentioned the need to handle the user input. If HTML is allowed, it is necessary to find reliable package to handle it. Many websites have such requirements, so browsers have gradually started providing related functionalities. Creating a new feature from scratch usually takes long time, from the proposal, specification and implementation, which can take several years. Okay, topics of trusted types and sanitizer API discussed in this article are currently only supported by Chromium-based browsers. They have not been officially supported in latest versions of Firefox, like this version, and Safari, this version. Therefore, the content mentioned in this article can be considered as the reference for future use production at the same time. That's right. Okay, so guess this the latest line of defense would only be applicable for Chromium one. So there is certain API. Hello. So yeah, I guess it's not also a really interesting read, because if it's only applicable for Chromium based. If it's applicable for all of the browsers, I guess we're gonna spend, but it's not really that much of interest, at least for me. So trusted types, okay, yeah. But bypassing those defenses, I guess those articles will be, those posts will be way more interesting. So we're gonna continue tomorrow as well to see some of those bypasses. And I might, before the stream, I might create the lab, multiple labs, just to like play with CSP bypasses, probably, if I have enough time. Unsafe domains, but yeah, I guess I'm gonna need to purchase certain domains probably for that, unless I will find some CTF challenge. Welcome to the stream. But yeah, this is like actually the end of the stream. Usually the streams take around 1 hour or so. So yeah, this, I'm just planning what I gonna read for the next stream and probably what I will be doing as well. Or tomorrow I could also, what I could try is to do a little bit of recon as well, if you want. So I guess I gonna create poll in the Discord for the people to see which type of content they want. But I want to finish what I started, at least this part. So this still gonna be part of the plan. But yeah, it was my pleasure exploring these topics. Some of those, like most of the things I already know, some of the things are not really interesting. API exploitation in detail. All right, I could do that as well. All right, because I gonna need some breaks of between reading articles for sure. But this month, I guess it's called back to school month. So what I wanted to create during these streams is like reading some articles, reading some content, like top-notch content, and I guess that's pretty interesting areas to look for sure. So yeah, that's gonna be it for today, and looking forward until tomorrow.